Hi everyone, I'm going to discuss about Pauli's exclusion principle. We have seen that wave function of a system of spin half particles is antisymmetric. Let us consider a system of two spin half particles. Let the quantum states available to the particles is represented as phi alpha 1 and phi alpha 2. Then we can write the possible state of two particle system as psi of 1 2 is equal to phi alpha 1 of 1 into phi alpha 2 of 2. Let it be equation number 1. So that the wave function of the system is given by psi a of 1 2 is equal to 1 by root 2 factorial into 1 cap minus p1 2 cap into psi of 1 2. We know that psi of 1 2 is the possible state of two particle system. Psi a of 1 2 is the antisymmetric wave function of the system and p1 2 cap is the exchange operator. We can write p cap 1 2 is equal to plus or minus 1. We know that wave function of a system of identical particles is either totally symmetric or totally antisymmetric. It is discussed earlier. Substituting equation number 1 in 2, we can write it as psi a of 1 2 is equal to 1 by root 2 factorial into 1 minus p1 2 cap into phi alpha 1 of 1 into phi alpha 2 of 2. By multiplying we get 1 by root 2 factorial into phi alpha 1 of 1 into phi alpha 2 of 2 minus phi alpha 1 of 2 into phi alpha 2 of 1, since p1 2 cap is equal to plus or minus 1. We can write it is in the form of a determinant, that is psi a of 1 2 equal to 1 by root 2 factorial into a determinant phi alpha 1 of 1, phi alpha 1 of 2, phi alpha 2 of 1, phi alpha 2 of 2. Let it be equation number 3. We know that if any two elements of a determinant are same, the determinant vanishes. Obviously, psi a of 1 2 vanishes if phi alpha 1 is equal to phi alpha 2. That is, it is not possible for the two particles to occupy the same state. This is known as Pauli's exclusion principle. The equation 3 can be generalized in the case of n particle system. Then we can write psi a of 1, 2, etc. n is equal to 1 by root of n factorial into determinant of phi alpha 1 of 1, phi alpha 2 of 2, etc. phi alpha 1 of n. Then phi alpha 2 of 1, etc. The last element is phi alpha n of n. It is an n by n determinant. This determinant is called as Slater determinant. The Slater determinant can be defined as an n by n determinant, which involves one particle states only. It may be asked in our exams. Since the determinant vanishes when two rows are identical, the exclusion principle follows. In the case of bosons, the wave function is given by psi of 1, 2, etc. n is equal to 1 by root of n factorial delta sigma p cap phi alpha 1 of 1, phi alpha 2 of 2, etc. phi alpha n of n, where delta is the factor which depends on the number of particles occupying the same state. The above equation does not vanishes when any two alpha I are equal. Thus, we can say that the bosons does not obey Pauli's exclusion principle. Thank you.